For the titration experiment, we start by weighing an empty weigh boat on an analytical balance. As you can see, it weighs 3.3237 grams. We have added the unknown acid to our weigh boat, and the weigh boat plus that unknown acid weigh 3.5718 grams. We now add the acid to a 125 ml Erlenmeyer flask, and it is sticking to the weigh boat. So I'm going to add some water to the weigh boat so that it will transfer into the Erlenmeyer flask. We want to get all of that acid in our Erlenmeyer flask. It doesn't matter how much water I add, because all we care about is the mass and ultimately the moles of acid in our flask, not the molarity of our acid. We have conditioned the burette using water and then some sodium hydroxide, our solution, and we have gotten all bubbles out of our burette area, and we are ready to make our initial burette reading. It is 1.00 mLs. We will now start our titration once we've added the phenolphthalein to our flask containing the acid. 2 drops of phenolphthalein, where that is our indicator. So we swirl everything to get ready to go. This is colorless, and as the sodium hydroxide reacts with the acid, it will slowly become a slight pink color when we are at the end point, the equivalence point. So we begin the titration by adding some sodium hydroxide. Notice when we first add the sodium hydroxide, because of the phenolphthalein, it turns a pink color. But then as we swirl and that sodium hydroxide reacts with the acid, the pink color goes away. The indicator phenolphthalein is only pink when we have the base around, a little bit of extra base. Also, as we add the base, we can clean the insides of our flask with distilled water. It does not matter how much water we add, provided we have room in our flask. So I will continue the titration and come back when we're at the end point. We are at the end point, and the final volume is 22.37 mLs. The end point is the point where the flask is just slightly pink. We see the slight pink color in the solution. That means there's a portion of a drop of sodium hydroxide just beyond the equivalence point, which means the end point. Now, from the volume of the added sodium hydroxide and the molarity of the base, the molarity of the sodium hydroxide is 0.1035 molar. From those two, we can determine the moles of the base that we added. And from that then, if it's a monoprotic acid, we have a 1-to-1 ratio between the base and the acid. So we can determine the moles of the acid. We have the grams of the acid, and then we can determine the molar mass. If it's a 2-to-1 ratio because we have a diprotic acid, well, we still know the moles of base, and then we make the conversion between the moles of the sodium hydroxide to the moles of the acid, so it'll be a 2-to-1 conversion, and determine then the moles of the acid, and again we can get the molar mass.